Hi guys, I hope all is well. So today we have an O-level past paper question from the year 2018. The session is May-June. This is question number 5. We'll look at how to find arc length, the shortest distance and the curved surface area. So let's start. In this question, they've given us a sector of a circle OAB with the center O and a radius 11 centimeters. AOB is equal to 134 degrees. Part 1 says calculate the length of the arc AB. That means we have to find the length of this arc right here. How do we find that? So the area, the formula for the length of the circumference, I just write CIR, is 2 pi r. But since this is not the entire circle and we just need part of this circle, which represents 134 degrees, so we multiply this by 134 over 360. So let's plug in the values and let's find out the arc length. So 2 times 3.142 times 11 times 134 over 360. I'll just plug this into the calculator and we'll find the arc length AB. So 2 times 3.142 times 11 times 134 over 360. This gives us 25.7, which is the arc length, 25.7 centimeters. So we write the value over here, 25.7. The next part says calculate the shortest distance from O to the line AB. So that means they've asked us to find this distance right here. This would make a 90-degree angle with AB. So we have this over here. That's the hypotenuse of this triangle. If we calculate this angle right here, we would use trigonometry to find the length of OX. Let's call this point X. So the angle over here, if you divide 134 by 2, this is going to be 67 degrees. So let's use trigonometric ratios to find the length of OX. So let's, what's the angle? AOX. AOX. And what are we trying to look for? OX over OA. That means it's the adjacent over the hypotenuse. So we use cos AOX. So cos AOX, the angle AOX we just found was 67 degrees and OX is what we are looking for and OA is 11. So OX would mean that we multiply 11 with cos 67. Let's do that. 11 times cos 67 gives us 4.3. So the length is 4.3. This right here is 4.3. Okay, let's move on. The next part of the question says, a cone has height 9.5 centimeters and volume 115 centimeters cube. Show that the radius of the base of the cone is 3.4 centimeters correct to 1 decimal place. In order to find this, we have been given the volume and the height of the cone. So we'll use the formula of the volume. Volume is equal to 1/3 times pi r square h. That's the volume of a cone. So let's plug in the values. We have 115, then 1 over 3 times 3.142. We don't know the radius squared times 9.5. I'll multiply 3 with 115 and then divide it by these numbers. So r square would equal to 3 times 115 divided by 3.142 times 9.5. Let's see what we get. 3 times 115 divided by 3.142 times 9.5. This gives us 11.56. So one second. If r square is equal to 11.56 and we find the square root on both sides, r would come out to be, one second, r would come out to be 3.4 centimeters, which is the same as mentioned in the question. Okay, let's move on. Calculate the curved surface area of the cone. So the curved surface area CSA can be found by the formula pi times r times L. L is the slant height. This height over here would be called L. If you're given the height of this cone, which in this case is 9.5, this is 9.5, and the radius of this cone is 3.4. Let's first find the slant height by using the Pythagoras theorem. How do we do that? So L square, since it's the hypotenuse, is equal to 9.5 squared plus 3.4 squared. L square is equal to, let's plug in these values, 9.5 squared plus 3.4 squared gives us 101.81. So L, you find the square root on both sides, would be equal to 10.1 centimeters. Now since we have the slant height, let's plug it into this formula over here to find the curved surface area. So the CSA would be 3.142 times the radius, which is 3.4, times the slant height, which is 10.1. Let's find what we get. Multiply 3.4 by this, by 3.142, and the curved surface area is 108 centimeters squared. 108 over there. The complete working of this entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.